Relativity question number 2 involves throwing things out of cars. Something I recommend you never, ever, ever, ever do. So, imagine you're driving forward in your car at your car's max speed. There we go, there's your car, there's your bumper, windows. And you're driving along at your car's max speed, and you throw something from the driver's side of the car. American cars, the driver's side is on the left. You throw something out. For the sake of argument, let's just say what you're throwing is a bone for a dog who's happy to receive it as he sits by the side of the road. There, what a happy dog that is. So, the question is, what is the trajectory? So, your car is going at its max speed. You're throwing the bone at your max speed. It doesn't have to be a bone, I'm just drawing a bone. So, this will be the max speed that you throw. This will be the max speed your car is going. And we want to find the resultant combined vector that the bone will travel. Now, my car's max speed is 42 meters per second. Yours in your biometrics page and probably a lot higher because you don't drive an economy electric car. Your throwing velocity, well, my throwing velocity was 19 meters per second. So, how do we figure this out? Well, there's two things we've got to figure out. One is the magnitude of our vector, and the other is the angle of our vector. Let us start out with the magnitude first. So, the magnitude, if you'll recall, a squared plus b squared equals c squared. A is 19 squared plus 42 squared equals c squared. So 19 squared is 361 plus 42 squared is 1764 equals c squared. You add them together and you get 2125 equals c squared. A lot of people just put this number down, but don't forget, it's not c, it's c squared. You got to take the square root of both sides. Take the square roots of both sides, you get 46 meters per second. So our answer is 46 meters per second. Except we're missing a direction. What is theta? Well, we got to figure that out. Now, going ahead here, theta is equal to the inverse tangent of the opposite over the adjacent. In this case, the opposite is the speed you're throwing at, and the adjacent is the speed of your car. So theta is equal to the inverse tangent of 19 over 42, which means that theta is equal to the inverse tangent of, I think the number I got was 0.452, and that gave me a theta being 24 degrees. Now, 24 degrees, which way is it? In this case, it's left of straight ahead. So this would be 24 degrees left of straight. I never actually tell you what direction the car is going, so left of straight would be fine. You just want to say this 24 degrees that way, not 24 degrees this way, or 24 degrees any other way. Now, couple things. How do you know if you're right? You can't check your answer against someone else's answer because other people have biometrics. But let's use a little bit of number sense. I got 46. Well, this is the hypotenuse. It's going to be the longest side. So it's got to be more than either side. Is it more than 19? Yes. Is it more than 42? Yes. Now, the hypotenuse is the longest side, but it can't be longer than the other two sides put together. So it cannot be longer than 19 plus 42. 19 plus 42 is 61, so it is less than 61. That number falls within the realm of believable numbers. Doesn't mean it's right, but we can, if you're going to do something wrong, you're probably going to be way off, not just off a little bit. So the fact that it meets those criteria means it's probably right. We can definitely say it's not way off. Same thing goes here. Now, most of you guys, when you're driving a car, your car is probably able to go faster than you're able to throw a ball or a bone. So this side is going to be longer than this side. That means that this angle cannot be more than 45 degrees. In order for this angle to be more than 45 degrees, that side would have to be longer. You'd have to be able to throw faster than your car could drive. Probably not the case. So you should be getting a number that's less than 45 degrees. In my case, I'm getting 24 degrees. It's only about half of 45. So that definitely falls in the realm of believable. So I look at this. Does this seem believable? It does. And that's good. Thank you.